Okay, so here we've got a sequence of numbers, and it's quite an easy sequence to spot. You can see that to get from one term to the next, we're just adding 2 on. Now, this type of sequence we call an arithmetic sequence, and we can characterize this as a sequence which has a first term which we call A, and to get each subsequent term, we're just going to add on a common difference D, which in this case is 2. But generally, an arithmetic sequence would look like this. Our first term would be A, our second term A plus D, our third term A plus 2D, and our fourth term A plus 3D. And we can actually see that our nth term for this series is going to be the first term A plus n minus 1 lots of our common difference. So for example, in the fourth term, we had 3 lots of our common difference. In the third term, we had 2 lots in our common difference. So in the nth term, we're going to have n minus 1 lots of our common difference. And we can write out the formula for this. un, we use u to refer to a term of a sequence, and n is the nth term. This is going to be equal to A plus n minus 1d. So that is your formula for the nth term of a sequence. Okay, so let's have a look at how to find the sum of the first n terms of a sequence. And we denote that as S subscript n, the sum of the first n terms. So if I was going to find the sum of the first 4 terms of this sequence here, I'll just add together these numbers. 3 plus 5 plus 7 plus 9, that gives me 24. So that's the sum of the first 4 terms of the sequence. But more generally, we can say the sum of the first n terms of the sequence is the first term plus the second term plus all the terms in the middle, plus the n minus 1th term, so that's going to be a plus n minus 2d, plus our nth term, a plus n minus 1 times d. Okay, so another way that we can write this sum is to do the same thing, but this time in descending order. So we've got a plus n minus 1d, our nth term. I'm just going to put brackets around these so we can know which term they are referring to. Plus our nth minus 1 term, which is a plus n minus 2d. All the terms in the middle, plus our second term, a plus d, and our first term, a. So what we can do now is we can add these two lines together. So if we add a plus n9 minus 1 lots of d, we're going to have 2a plus n minus 1d. And if we add a plus d plus a plus n minus 2d, again, we're going to end up with a, or 2a, we've got an a there and an a there, plus n minus 1 lots of d. And this actually happens for every term. We're going to get the same when we add these two terms together. We're going to end up with 2a plus n minus 1 times d. And the same for the last term. And on the left hand side, we've added together Sn and Sn, so we've got 2 times the sum to n terms. So what you can see here is we've actually got 1, 2, all the terms in the middle, n minus 1, n lots of this 2a plus n minus 1d. So we can write this in a simpler way. We can write this as n times 2a plus n minus 1d. So we're almost there for our formula for the sum to n terms. All we need to do now is just divide by 2, and we get the sum to n terms is n over 2, 2a plus n minus 1 times d. And that is our general formula for finding the sum of the first n terms. So I'm just going to put a little box around that. This is the formula. We're given this in the formula booklet in C1, but you need to know this proof of where it comes from. We've got an alternative form of this. Another way we can write this is if we just split up this 2a into an a plus a, and then we've got our n minus 1 times d. You should be able to spot that a plus n minus 1 times d is the same as our formula for the nth term of a sequence. So another way that we could find the sum of the first n terms is to do n over 2 times a, the first term, plus the last term of the sequence. So when we look in our example of finding the sum of the first 4 terms of this sequence, well, we could do 4 over 2, which is 2, times 3 plus 9, which is 12, so 2 times 12, which is 24. That can be a quicker way of finding that out.